Test. 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 Good morning. Test. Test. Good morning. Morning. Testing. Morning. Testing. Okay, this is very loud. This is super loud. Testing. Okay, this is very loud. This is super loud. Okay, this is very loud. This is super loud. Okay, this is very loud. This is super loud.
你就放在你的裤子里。OK， 带着。
这是啥呀？
这是麦。
小蜜蜂吗？哇！
屁！啊？麦呀？
啥麦？是录音的麦吗？还是？
对。
录哪去了？
啥？
录哪去了？
那边。
干嘛呀？
没什么干嘛。No. Independently, okay? I don't know that they want to record the class.
我们是不能聊闲话了。
No.
我们连聊闲话就被录进去了。
Okay, question number 1. Question number 1. Since I did not label the page number, the question number 1 is like y equals to sine x times cosine 2x, okay? Y equals to sine x times cosine 2x. Okay? So it says the curve with the equation y equals to sine x times cosine 2x has one stationary point in the interval from 0 to half pi. Then find the x coordinate of this point, giving your answer correct to 3 significant figures. It says the stationary point, of course you need to take the differentiation, but most of you, or say some of you, has forgotten about the chain rule, okay? The chain rule, especially when there are more formulas on the differentiation. So if y goes to this expression, then the dy over dx will be using the product rule, right? Using the product rule. So dy over dx equals to cosine x, and times cosine 2x does not change, plus sine x does not change, then times negative sine 2x. But please remember that this is the 2 after the sine. There's the 2. Then the 2 is from the differentiation of 2x. Okay? The 2 is from the differentiation of the 2x. So this is the expression, or this is the result from the differentiation. Sorry? Yes, you have to. Let's say there is the stationary point. Stationary point means that dy over dx equals to 0, right? If you want to solve this equation, you need to use the double angle formula, of course. When there is the single x and 2x cannot solve the equation, you need to change the 2x to be x. which one requests you to use the double angle, okay? Double angle formula. Let's say for the first one, it is like the cosine x. Then double angle from the cosine 2x, you have 2 times cosine x squared minus 1, right? Then minus 2 times sine x, then times 2 sine x cosine x. Then the 2 times sine x and cosine x is from the double angle formula for the sine 2x, right? For the sine 2x. Okay? This one can, right? Now continue with the simplification. You'll get 2 times cosine x cubed minus cosine x minus 4 times sine x squared and times cosine x equals to 0. I observe that the first term only consists of the cosine x. Only consists of the cosine x, right? So the second term, the sine x squared, you need to change it to be the cosine x. Cosine x. So if you continue, this is 2 times cosine x cubed minus cosine x minus 4 times bracket 1 minus cosine x squared, then times cosine x equals to 0. Okay, equals to 0. Okay. So combine the similar terms. Combine the similar terms. This one will get 2 cosine x cubed minus cosine x minus 4 times cosine x, right? Plus 4 times cosine x cubed equals to 0. So finally you get 6 times cosine x cubed minus 5 times cosine x equals to 0. Okay? Equals to 0. You can take out the common factor, factorize this expression. You get cosine x, then times bracket 6 times cosine x squared minus 5 equals to 0. Okay? So after that, you can get the value of cosine x either be 0 or the cosine x equals to square root of 5 over 6. Okay? And since the angle of theta is in the range from 0 to half pi, okay, then 0, this one, cosine x equals to 0 will be rejected. Also, another solution, let's say cosine x equals to negative square root of 5 over 6 will be rejected also. Okay? Since x is in the first quadrant, so cosine x has to be positive. Has to be positive. So based on cosine x equals to square root of 5 over 6, then what is the value of x? What is the value of x? Have you got the answers? Just cosine inverse square root of 5 over 6, right? 0.421, okay? 0.421. Can? Which cannot?
这个它这个地方，从 PVT 来看的话，它cosine 要矮
The derivative for the cosine 2x, the outside layer is the cosine, right? So the differentiation of the cosine will get a negative sign, but one time, one layer, okay? So inside layer does not change, so just put the 2x there, all right? 2x does not change, then times the differentiation of the inside layer, inner layer, okay?
Yes.
So the differentiation of 2x equals to 2, right? Differentiation of 2x will be 2. So just put 2 here. This is the chain rule. This is the chain rule. Of course, if you are not so familiar with the, let's say, the product rule or quotient rule, you may take one of it as u, another one is v. Then you calculate what is dv over dx and what is du over dx. Then you can apply the quotient rule or the product rule. All right? Okay? Question? Okay, this is question number 1. Question number 1, just the application of the product rule, okay, together with the trigonometry equation. So although this UA does not cover the topic of the trigonometry, but sometimes the trigonometric functions is in the differentiation. So you are not you are also required to know the formula under the trigonometry. Okay. Okay. Okay, right. Pass, question number 2.
number 1 嘛。
I said next one, question number 2. Sorry? Which one? Which step? Have you got this number? 1/6. Square root of 1/6. Sine. Sine is 1/6, not 1/5. You can check your answer again. Okay? So, question number 2. Question number 2 is the differentiation of the implicit function. Implicit function give you x cubed minus 3x squared times y plus y cubed equals to 3. Part 1 is to show that dy over dx equals to x squared minus 2xy, then divided by x squared minus y squared. So for this kind of differentiation, you just take the differentiation both sides of the equal sign, right? Which you can get 3 times x squared, okay? 3 times x squared minus 6x times y does not change. 6x is from the differentiation of 3x squared, okay? 6x is from the differentiation of 3x squared. Then minus 3x squared does not change. Then the differentiation of y, it is like dy over dx, okay? dy over dx. Okay? Then plus the 3 times y squared, then times dy over dx. For this one, the 3y squared is from the differentiation of y cubed. But inside the y cubed, there's the y. So according to the chain rule, we need to times dy over dx. Okay? Times dy over dx there. Then equals to the differentiation of 3, which is 0. Okay? Please take note, this is 0. This is 0. Some of you just forgot to take the differentiation of the constant. Still put 3 there. Okay? Should be 0. So next one, just for these 2 terms, you just take out the dy over dx. So that means dy over dx times 3y squared minus 3x squared equals to 6xy minus 3x squared. Okay? 6xy minus 3x squared. Okay? Question? So followed by dy over dx, then equals to 6xy minus 3x squared, and divided by 3y squared minus 3x squared. Just cancel the common factor, which is 3. So we'll get 2xy minus x squared, right? Divided by y squared minus x squared. Okay? Then both numerator and denominator times -1. To make it identical with the expression given by the question. So it is x squared minus 2xy and divided by x squared minus y squared. All right? Like this. Any question? And if no part 2, find the coordinates of the point on the curve where the tangent is parallel to the x-axis. Tangent is parallel to the x-axis. Let's say if the tangent is parallel to the x-axis, that means the gradient equals to 0. The gradient can be represented by dy over dx. All right? That means just dy over dx equals to 0 to guarantee that the tangent is parallel to the x-axis. So if dy over dx equals to 0, from the result from part 1, you can say that x squared minus 2xy equals to 0, right? But of course, if you just use the x squared minus 2xy equals to 0, there's no way to find out the coordinates, right? So you have two unknowns with just one equation. So for this one, you need to combine with the original equation. Let's say x cubed minus 3x squared times y plus y cubed equals to 3. Then you solve those simultaneous equations. You can get the value of x and the value of y. All right? Let's say how. From the first equation, you can deduce that you can take out the x, which means x times x minus 2y equals to 0, okay? Equals to 0. So you can deduce that either x equals to 0 or x equals to 2y. Either x equals to 0 or x equals to 2y. Okay? When x equals to 0, then the value of y will be cube root of 3, okay? When x equals to 0, just this 2 equals to 0, y cube equals to 3, so y equals to cube root of 3. Then when x equals to 2y, so this 2y cube minus 3 times 2y squared times y plus y cube equals to 3. Right? So in this case, what is value of y? Sorry? Negative 1. Is it? Negative 1. So you have 2 points. You have 2 points. The first one is 0 cube root of 3. The second one is negative 2 and negative 1. Okay? Negative 2 and negative 1. Okay? Question? Any point not so clear? Sorry? No, just recording. Recording. Huh? 2 points. Just now I mentioned that 2 point, right? 0 cube root of 3. Next one is negative 1, negative 2, and negative 1. Negative 2 and negative 1. Okay? Sorry? What's wrong with your calculation today? Huh? 1 negative 1. Why 1 negative 1? Okay, let's say these two we can get, right? Why? Cannot, you cannot just ignore x. Which original? This one. Let's say if you sub y equals to -1 back to this one, you may calculate another point, another value which does not satisfy the first one. Okay? So you need to check whether your solution satisfies both equations or not. You cannot just get the roots from the second equation directly. Okay? The solution is like this. Let's say you have the equation like x minus 1 equals to 0. X minus 1 times x minus 2 equals to 0 also.
吓我一跳，我以为是朝我。没事，导演继续。这个带上，这个带上。
Okay? So let's say if you want to solve this simultaneous equation, so you cannot say x either be 1 or x equals to 2, okay? It is because x equals to 2 does not satisfy the first equation. You cannot say x equals to 1 or x equals to 2. Both are the solution of the simultaneous equation. Understand? X equals to what? So just take out the x, right, to be here. X times x minus 2y equals to 0. So either the first factor equals to 0 or the second factor equals to 0, right? Okay? 2 points, 2 points.
怎么知道说它有两个点？
Huh?
怎么知道说它有两个点？
Which step is not clear?
是最后一个，它有两个点，就只
So from the first equation, deduce that either x equals to 0 or x minus 2y equals to 0, right? Is that clear? So just consider case by case. When x equals to 0, can deduce the value of y. When x equals to 2y, and can also deduce the pair of roots, right? X equals to, let's say, -2, y equals to -1. Okay? We'll get at y equals to -1. Considering this one, the value of x only one value, so cannot be two value. X just equals to 2y, okay? Equals to -2. Yes? Question? Ken? So any other points on question number 2? Why shake your hand? Question? No. Now then question number 3. Question number 3, also a lot of students have no idea how to take the integration or take the integration wrongly. Okay, let's talk it one by one. I mean u and v. So question number 3 gave you y equals to ln x, the whole expression square, then divided by x, all right? Divided by x. So let's say for this one, we can take ln x square as u and x as v, right? U equals to ln x square, then v equals to 1, okay? So now what is du over dx? dv over dx is easy to get, right? Okay? So what is du over dx? The outside layer is square, right? So the first step is to take this differentiation of the square. So it is 2 times ln x does not change. Somebody just write 2, 1 over x. Cannot, Cannot be like this, So it is like 2 times ln x with the power of 1 actually, then times the differentiation of the ln x, times the differentiation of ln x, which is 1 over x. So just now I said dv over dx is easy to find. This is x, should be 1, okay? Okay. So with the quotient rule, you can deduce the expression for dy over dx. This one will be x squared, then 2 times ln x times 1 over x times x does not change, and times the ln x squared, and times 1, okay? This is the result of the differentiation. Yes? Why? Okay. Let's consider this one. Y, if y equals to ln x squared, right? The chain rule says that if you take ln x as u, y will be u squared, right? Is it clear? So the dy over dx equals to dy over du, then times du over dx, right? So now what is dy over du? What is dy over du? 2u, right? What is du over dx? 1 over x. Is there a square? No. So just times the differentiation of the expression under the square, that will be enough. Since you have taken the differentiation of the square, so there is no square anymore, all right? Just times the differentiation of ln x. That's all. All right? Go back. This one. Okay? Then find the exact value of the coordinates of those points. Those points means the stationary point. You can simplify it a little bit further. Then 1 over x times x will be 1, right? So just 2 times ln x minus ln x squared and divided by x squared equals to 0. Equals to 0. Also take out the ln x. Please do not eliminate the ln x. Okay, take out the common factor. So it is like ln x bracket 2 minus ln x equals to 0. Okay, so ln x can be 0, right? Ln x can be 0. So it is like ln x equals to 0 or ln x equals to 2. Okay, ln x equals to 0 or ln x equals to 2. So if ln x equals to 0, what is the value of x? Will be 1, right? If ln x equals to 2, x will be e squared. But the question is asking for the exact value of the coordinates, including the value of y. If x equals to 1, y equals to 0 also, right? Since ln 1 equals to 0. If x equals to e squared, what is it? Huh? Huh? They have 4 over e squared, right? Okay. Ln x will be 2, right? Ln x will be 2. 2 squared, 4. 4 divided by x, which is e squared. So it is 4 over e squared. Okay. Again. Please do not eliminate ln x. Take it out. Okay? Okay? The reason is you cannot guarantee that x is not 0, or the ln x is not 0. Okay? Question? Oh, cannot be like that. The reason is you just read through the question, especially for the last sentence. What did it say? Exact value. No, that is not exact, huh? I'll give you an example. Suppose you have the, let's say a equals to pi, or a equals to 3.14. Which one is exact value? Huh? Which one is exact? Of course, the pi, right? Pi is exact. So the 0 point blah, blah, blah is not exact. Okay? No more question. If no, let's talk about the parametric function. Differentiation of the parametric function. Question number 4. Question number 4 gives you x equals to t plus cosine t, then y equals to ln 1 plus sine t. And t is in the range from negative pi over 2 and pi over 2. Then first one is to show that dy over dx equals to secant t. Just like I mentioned that although the trigonometry is not in the scope of the UA, but sometimes you need to still use the trigonometric identities. Okay, let's say for this one. The parametric function, the first step is better find out expression for dy over dt and dx over dt. Y is given as ln 1 plus sine t, so the differentiation of this expression is like 1 over 1 plus sine t and times cosine t, according to the chain rule. Okay, the chain rule. Okay. All right. So also for the dx over dt, x equals to t plus cosine t. It is 1 minus sine t, right? 1 minus sine t. So finally, you can get dy over dx equals to cosine t over 1 plus sine t divided by 1 minus sine t, right? Okay. Then simplify it. You'll get a cosine t divided by 1 minus sine t squared, which is cosine t over cosine t squared, which is 1 over cosine t, right? Equals to secant t. Secant t. All right? Question? Then part 2, hence find the x-coordinate of the point on the curve at which the gradient is equal to 3. Okay? And give your answer correct to 3 significant figures. Let's say if the gradient equals to 3 means dy over dx equals to 3, right? So it goes to secant t equals to 3. If secant t equals to 3, the cosine t will be 1 over 3. Will be 1 over 3. All right. Of course, you need to calculate the value of t. In the range from negative pi over 2 to pi over 2. So now what is the value of t? What is the value? Hmm? Two values, right? 1.23 or negative 1.23. Okay? So let's say when t goes to 1.23, the value of x will be 1.556, right? Next one. Okay? These two values are correct to three significant figures. Cannot use the 1/3. Cannot use 1/3. Just with your calculator, you can get the final final answer correct to three significant figures. Cannot just stop at the 1/3. Okay? Sorry? Use what? Cannot. When you have the coordinates, better use the reading coordinates. Let's say if it is in the trigonometry, just asking you the angle of theta or angle of x, you can use the degree if there is no special requirement. But for this chapter, especially for the differentiation, when you calculate the coordinates, better use the reading. Okay? And reading and real numbers is 1-to-1. Okay? Question? If not, then question number 5. Question number 5 also about the differentiation of the trigonometry, not trigonometry, parametric. Of course, involving trigonometry. But this time I will not use the dx over dt and dy over dt. I will write the answer directly. So for this one, dy over dx equals to dy over dt equals to 3 minus secant theta square, right? Then divide by 1 over cosine theta times negative sine theta. Numerator is dy over dt. Denominator will be dx over dt. Okay? Please take note. Be careful about the chain rule. Be careful about the chain rule, all right? It is like 1 over cosine theta times negative sine theta. Okay? So simplify it. For this one, you have negative tangent t, right? Negative tangent t. Or not t, but theta. This one will be theta. Then the numerator, you can change the sine theta square to be 1 plus tangent theta square, right? 1 plus tangent theta square. So just I mentioned that you need to know the trigonometric identities. Trigonometric identities. All right? Okay. So what is the final answer? After combining the two constants. Huh? No, I mean the expression. Tangent theta square minus 2 divided by tangent theta, right? So this is answer for part 1, just for part 1. Okay. Then part 2 is just that find the exact y coordinates of the point on which on the curve at which the gradient of the normal equals to 1. Gradient of normal, please be careful. This is normal instead of the tangent. So you need to convert the gradient of normal to the gradient of tangent, right? So let's say the gradient of tangent equals to -1 equals to -1. That means tangent theta square minus 2 divided by tangent theta equals to -1. Okay, equals to -1. So rearrange this one, you get tangent theta square minus 2 equals to negative tangent theta. So tangent theta square plus tangent theta minus 2 equals to 0, right? So now what is the value of tangent theta? Either 1 or -2, right? -2. But we know that theta is in the range from 0 to half pi. So tangent, this is the quadratic function, right? Is it? This is the quadratic function. Normally we'll have 2 roots, but theta is in the first quadrant. So tangent theta has to be positive. So the -2 will be rejected. Okay, -2 will be rejected. So let's say if tangent theta equals to 1, then the theta will be pi over 4, right? Theta will be pi over 4. Okay. Question? If theta equals to pi over 4, then y will be 3 pi over 4 minus 1, okay? 3 pi over 4 minus 1. Okay? The question also asks you about the exact value. Exact value. So when I speak English, you just ignore it. Right? Just like I mentioned that the theta is in the range from 0 to half pi, so tangent theta is positive, right? So the -2 is rejected. Plus pi, it is in the range from 0 to half pi. Is it? Of course not. You plus pi. Pi is even larger than the pi over 2, so cannot. Can? Is it clear? Okay, question number 6. Question number 4, 5, 6, all about the parametric equations. Parametric equations. Question number 6, give you x equals to t squared plus 1, then y equals to 4t plus ln 2t minus 1. Then express dy over dx in terms of t. So in this case, dy over dx equals to 4 plus 1 over 2t minus 1 times 2, then divided by 2t plus 0, okay? Divided by 2t plus 0. For this one, I can simplify it. Both the numerator and denominator times the 2t minus 1. So you get 4 times 2t minus 1 plus 2 divided by 2t times 2t minus 1. So if you combine the constants, you'll get 8t minus 2, okay, divided by 2t times 2t minus 1. Can cancel the 2. Can choose cancel the 2, which is 4t minus 1 divided by t times 2t minus 1. Okay? Can? 醒醒。No. Not yet. Sorry? Oh, I don't know. I'm not sure. Okay, so this is the expression for dy over dx. The next one is find the equation of the normal. Find the equation of the normal to the curve at the point where t goes to 1. T goes to 1, normal. So let's say when t equals to 1, the value of x will be 2, right? Since x equals to t squared plus 1. Then the value of y will be 4 plus ln 1, right? Ln 1 equals to 0. So just y equals to 4. Then the dy over dx will be 8 times 2 minus 2, and divided by 2 times 2 times 2 times 2 minus 1. Okay? So the value of this one will be what is this value? Should be 3, right? 3. So the gradient of the normal is, yes, it's negative 1 over 3, right? So the equation of the normal is like y minus 4 equals to negative 1 over 3 times x minus 2 here. All right? Ken? You can simplify it. And the final answer is just like y equals to negative 1 over 3, then plus 14 over 3. Okay? 14 over 3. Okay? Sorry? Oh, x, sorry. Here's the x. Question? Danhuai. Any point also clear? Yes. Hmm? Oh, yes. You can continue with the rearrangement. So the final form is like 3y plus x minus 14 equals to 0. Okay? Okay?
对不起，对不起，对不起。
Very good. The BGM is like.
我不小心碰到了。
嗯。
我把它关掉。
Okay. So for this class, I just stop here. You can continue trying the rest of the question. All right. 不想结束。啊 ？Why 啊 ？Okay. You can take a break. Hey, what's next lesson? Sorry? Oh, chemistry. All right, all right. What is chemistry?
Mystery. 可以把这个答案发到群里。
可以，但你也得听。 那个答案不太
我就是
不太详细，
自己对一下。
可以可以。
有，
要给你摘了。
对对，谢谢你，谢谢你，
讲的老好了，
谢谢你，谢谢你。
一直在听。
等一下，下一课是哈菲斯，等一下给他。再来一个。对。收了。
准备录下去。
对。没事，我关了就好。
So I click here.
Can I talk using open my mask? Does not reach on open
No,
my.
it did not.
Damn it. Okay. Okay. I feel like a puppet, right? All right. So this one here, part 4, compounds containing I minus, contaminated by Br minus. Okay. So this one here, what you need to do, you just need to add the ammonia, right? Add the dilutes. Okay, ammonia. Okay, because why? This one here, AgI, is it soluble in ammonia? Okay, it's actually insoluble. Yeah, insoluble, sorry, in NH3. Okay, this one here is a soluble. Okay, it's a partially soluble, right? Partially soluble. Okay, okay. Any questions? So that is the answer for part 4. All right, to show that the precipitate form contains iodide ions. Okay. So means, right, if you add the NH3, it means some PPT dissolve, right? Means what? Means you have the Br minus inside, which is contaminated. Okay, which is contaminated. All right, so copy this down now. Okay, now let's take a look at the next question, part C, right? C part 1. Can I erase? Can. All right, so for C part 1, draw a dot and cross diagram to represent the bonding in a molecule of a HOF. Right, so for this one here, dot and cross, one is dot, one is cross. Okay, you need to draw the key also. Okay. So for this one here, oxygen, okay, so oxygen here actually got 6 electrons, right? So 6 electrons, okay, and then it will form a covalent bond with a hydrogen. Hydrogen only got 1, and then fluorine only got 7. Okay, so like this, okay, all right, and then do not forget to draw the key, right? The key. Okay, so it means what? Means the X, what does it mean here? It means the oxygen electron. Okay, oxygen electron. Okay, what about the dot? Okay, it's just the H and the F electron. Okay, right. Please behave, you are being recorded. Okay, so please behave. All right. Okay, do not be unattentive. All right. Now, let's look at part 2. Right. HOF can be made by the reaction of F with ice. Okay, at minus 40 degrees. So the reaction is the similar to the reaction of a Cl2 with cold water. Okay. So this one, remember, Cl2 with cold water, what do you get? Okay. All right, so this one here, Cl2 plus the H2O, what would you get? You get HCl, and then plus what? Another compound that you get here is a HClO. Okay, this is in your group 7, right? In your group 7, so must remember this equation. Okay. Do you know what is the name of this compound here? Okay, what is the name of this compound? The name of this compound here is a chloric. Okay, 1 acid. Okay, chloric 1 acid. Okay, so this one here, I think some of you might forget already, right? This is one of the reactions that is inside in group 17. Okay, so now you know this, I just change the chlorine to fluorine. Okay, so this one here, F2 plus the H2O, then you get a HF plus a HOF, right? Or HFO also can, doesn't really matter, all right? All right, any questions for this one? Okay, Now, for part 3, right, they say HOF is an unstable compound, okay, and it decomposes to form HF and O2, right? So I'm going to erase this. Okay. Now, if you take a look at the reaction here, what do you need to know, right? Look at the value of this one. It's a negative, so it's an exothermic. Okay, exothermic, right? So means what? Okay, so you need to draw what? So remember this one here, the enthalpy H is just the energy of the products minus the energy of the reactants. Okay, so if your enthalpy H is a negative, who has the higher energy? Is it product or reactants? Okay, let's ask Borui. Which one got the higher energy, products or reactants? Okay, please wear your mask. Liu Chang, right? Wear your mask. Okay, right. So this one here, what is this here? So means the reactants is higher in energy. Okay, so means the reactants here is higher in energy than the products. Reactants is higher in energy. Okay, right. So now how to draw the diagram? Okay, so you need to draw like this. Okay, and then just label. This is the reactants HOF. This is a HF plus a half O2. Okay, like this, right? And then what else do you need to label? Okay, you need to label the enthalpy H. Right, so now when I want to label the enthalpy H, is the arrow going up or is the arrow going down? Okay, take a look here. This is a negative, right? So to indicate that it's negative means the arrow here go down. Okay, so it's a minus 139. Okay, and then remember what did I tell you? Every time you draw this diagram, you must also label the correct. So you must label the activation energy. So remember, activation energy is from the reactants to the highest point, EA. Okay, do not forget these two. Make your answer as complete as possible. All right. Okay. Any questions? No, huh? All right. Now let's turn to the next page. Okay, so for part 4, right, this one here, pure HF is a colorless liquid. The liquid HF contains molecules that have strong hydrogen bonds. Okay, so draw a diagram to show the hydrogen bonds. Okay, this one here, just draw one hydrogen bond is enough. Okay, no need to draw two. Some of you draw two. One is enough. So now when you draw the molecule of a HF, need to draw the valence electrons for the F, right? So this one here got a dot, okay, like this, and then draw another HF molecule. Okay, now every time when you want to draw the dipole, when you want to draw the H bond, you must remember the word here, dipole. Okay, do you know what is a dipole? Means it refers to your S plus and S minus. Okay, so which atom here is a S minus? Which atom is a S plus? Correct, so H is the H plus, right? S plus, sorry. This F here is the S minus, okay? And then what's next? If you want to draw hydrogen bond, it must start from the lone pair of the S minus atom, okay? And then it will go to the S plus. So now once you draw this, please label the hydrogen bond, right? So this one here, write down hydrogen bond. Okay, right now it seems very easy for you, right? But actually during exam, I see so many mistakes. For example, you draw like this, okay? HF, then you just draw like this, okay? Can you see what is missing here, right? The lone pair is missing, right? Must draw the lone pair. What else is missing? Okay, the dipole is also missing. All right, so you must draw the dipole. All right. Okay, so make sure when you draw hydrogen bonds, be aware of the requirements for the hydrogen bonds. Okay. Right. Okay, so copy this down. Okay. Right. Now let's take a look at option D. Okay. By the way, when you look at option D, do you see the questions a bit familiar? Do you remember this question? Okay. This question here is the same question that I put inside your unit assessment, which is like 4 months ago, right? Yeah, so the 2 previous unit assessment. Okay. So if you see this, you should be familiar with the questions, right? Okay, but I'm sure you guys all forget already, right? Okay, never mind. Okay, so now let's look at D, right? So for D here, you have the interhalogen compounds, right? So either BrCl or IF, right, contains 2 or more halogen atoms that are covalently bonded, right? So can be FF, can be FCl, or maybe can be CLF, right? Either one, we don't know, right? So now they say here D is an interhalogen compound that contains only chlorine and fluorine. Okay, so means D here is a ClXFY. Okay, because we don't know, right? We don't know how much is it. Then they say here at this temperature, this pressure, it has a mass of this one. Okay, so now what can you do here? You do the ideal gas formula, right? The general gas equation. So it's just the PV equals to nRT. Okay, PV equals to nRT, right? Okay, remember this? Okay. Then can you see here, this n here I can further change into the mass over mR, right? So this one here, PV, the mole, remember from our chapter 1 is equals to mass over mR. Okay. So this one here, mass over mR. Okay, like this. So just make mR the subject. That's all. Right, just make mR the subject. Okay, so another problem for the students is that when they key in the value, right, they never key in with the correct units. Okay, that's the only thing that you can get wrong. So for mass here is always gram, 4.13. R here is 8.314. Okay, inside your data booklet, right? Temperature, right, must be in Kelvin. This is in degrees Celsius. So you need to add 273.15. Okay, pressure, this is the correct units, right? Pascal, this is the correct units. So it's a 101.325. Okay, the volume here, right? Do we use dm cube? Yes or no? Right, we use a meter cube, right? So this one here you need to change. 1 times 10 to the power of minus 3 meter cube. Okay, 10 to the power minus 3. Right, so now when you key in the value, right, you should supposed to get the MR of 92.4 or 5. Okay, around this value, 92.5. Do you get this value for those who do it? Okay, yeah. Okay, good. Okay, have you guys done part 2 already? Yes or no? Okay, so can you please try to do part 2 now, right? Find for me what is the formula. This is a guess and check because why? We know the MR already. Okay, so please look at the formula. And then they also give you the clue, right? Only got chlorine and fluorine. Okay? Say again? Okay, so Borowi actually come in.
Sorry, teacher, Mr. Owen just left our school.
Sorry, what do you say?
Mr. Owen.
Oh, Mr. Irwin. He's no longer working here, by the way. Right. Okay. So now, this one here, Borowi asked a very good question. Do we use 92.5 or do we use 130.5? Okay. If you feel that your answer is correct, which is this one, use this one. Okay. But if you feel that your answer is wrong or you are unable to get the answer, you use this value. Okay. So what's the point here? The point here, if you get an answer, you will use this answer. But if you don't know how to find, just use this value. Okay, you will still get the working mark. That's the important part. All right. Okay. All right. Right. So now let's take a look at the question. Right. CLXFY equals to 92.5. Okay. So are you able to find? What's the answer? CLF3, right? CLF3, this one here is the 92.5, right? Chlorine here is a 35.5. What is the MR of a fluorine? Do you have your data booklets? Is it 19? Have you checked the data booklet? Huh? Okay, so 19 times 3. Right, so this one here, you will in the end get this answer, 92.5. It's a guess and check. Right, sometimes you try this one here, Cl2F2. When you get the number here, this number is not 92.5. It's not. So that's why you can eliminate this answer. Right, you need to try. Okay, try to find. Okay. Right, so now let's continue with question 3. Right, question 3 here is your organic chemistry already. Okay. Okay. Copy this one first. Yes, Liu Chang. Meisha, don't want to ask? Okay. Right, so now let's look at the next page. Okay, so just copy this, CLF3. That's the answer. Okay, now let's take a look at question 3. Right, question 3 here all contains 5 carbon atoms. A student carry out a test to distinguish between P, Q, and R. Right. So for this one here, what can you see the observation when you react with a sodium? Okay. So for P here, which functional group will react with the sodium? Okay. Do you remember from your organic chemistry? What are the functional group? There's 2 functional groups. Yeah, so alcohol and the carboxylic acid. Do we have a carboxylic acid here? Don't have. Alright, so this one here you will see bubbles. Okay, this one here no reaction and no reaction. Okay, right. This one here 2,4-DNPH. Okay, I have some good news for you guys. No need to memorize the full name of a 2,4-dinitrophenylhydrazine. Just write this one will do. Okay. Good news, right? After so many bad news, right? Okay. Right, so this one here for 2,4-DNPH, yes, it's a ketone, so you will see an orange PPT. Okay, do not write PPT, write precipitate. Okay, do not be short form. Precipitate. Okay, and then this one here also precipitate because there's an aldehyde, right? Orange precipitate. Okay, right. Now, next one here, acidified potassium dichromate. Okay, so basically just need to know that this is an oxidizing agent. Okay, so now can these compounds be oxidized? So that's the question, right? So ketone definitely cannot be oxidized, no reaction. Okay, this one here, aldehyde, can be oxidized, so just say become green. Okay, orange change to green. Yeah. Any issues? Why is it green? So because if you take a look at the oxidizing agent, right, this is a dichromate. The identity, the color of this one here is orange. And then you know the definition of an oxidizing agent. It itself will be reduced. So it will be reduced to what? Cr3+. So this is color green. Okay, if you ask me why green color, why orange color, you will study this in A2, not now. Okay, the colors you can study later in A2, not now. Okay, concentrate on your AS first. Okay, another one, another oxidizing agent that you remember is what? MnO4 minus, right? Which is the purple to the Mn2 plus, colorless. Okay, so please remember these two color change, right? This one here is also reduced, right? Okay, any issues? Okay, don't have, right? Now, let's take a look at the next question, which is part B. Right, so this one here, Q is reduced to what? Okay, so what is a Q here? It's a ketone, so it can be reduced to a secondary alcohol, right? So this one here, they say use a H, right? So okay, use a H. So now for ketone, right, what can you see here? It will become a secondary alcohol. Okay, so can you see how many H do you gain? Right, you gain actually 1 and a 2H. Right, so you gain 2H. So just put a 2 here. Okay, and then you will get a C5H12O. Okay, good. The H is present in BH4, correct? But they say here what? H is to represent NaBH4, right? So no need to think like that, just think as a whole, right? Just think as a whole, okay? Just say from here to here it gained 2H. So I know what you mean. What you mean here is that this one comes from the BH4 minus, right? This one here comes from the other places, but you're not required to know that. Just need to know that you gain 2H, that's all, okay? Because why? No need to study the mechanism of this reaction, okay? So no need to study the mechanism of this reaction, all right? Any questions? Okay. Right. Now, let's look at the next question, part C, right? Yeah, so this one here, R exists as a pair of stereoisomers. Identify the type of stereoisomerism. Okay, so let's look at compound R. This one here is a trans, right? Because it's diagonally opposite. So it means this one here must be a cis. Okay, so what is the name of this isomer here? Okay, geometrical. Can also cis trans. Okay, but I tell you first, geometrical is a better word. but in this case here, they accept both answers. Okay. So this one here, just draw the cis isomer, right? Okay, just draw the cis isomer. Actually, it's this one, right? CH2, right? Okay, the bigger MR must be on the same side. Okay. Can? Okay. Okay, now let's take a look at part B, right? This one here is talking about the infrared spectrum shown correspond to one of P, Q, or R. Okay, so deduce which compound is it? Is it P, Q, or R? Okay, explain your reasoning. Okay, so for this one here, you need to identify what bonds is it. Okay, so now I want you to take a look at this one here. Right, take a look at this value here, 2250. Okay, what is this bond here? Okay, if you do not know, take a look at your data booklets. All right, 2250 cm minus. Okay, refer to your data booklet and there you check. What is this, right? So you have your data booklet. Okay, so it's your C triple bond N, right? So this one here is your C triple bond N. Okay, another one here is what? Okay, because the only one with the C triple bond N is the P, right? So let's double confirm. Does it have a OH? Right, so now let's look at OH. OH here, according to the data booklet, is around 3,400, 500, right? So this one here is this one, OH. Okay, OH. Right, can you see it looks a bit complicated, but actually it's very easy. Just identify. This shape here is a very common, right? It's a OH. Okay, right, so this one here answer is a compound P. Okay, so how do you explain? So just say here, hold on. Okay, absorption. Right, so please write this word here, absorption, right? Absorption here means is the value here, right? The value go down because why it is being absorbed, right? So absorb at which value? At, okay, 2250 represents what? Represents the C triple bond N bond. Okay. Then what else? Another one here is this one, right? So around 3,400. Okay. Okay, do not forget to write down the units cm minus 1. Okay, represents what? Okay, represents the OH bond. Okay, represents the OH bond. Okay. Compound P. Any issues? Can Yes, Chen Yuxuan. Okay, so last question for this paper. Let's take a look at question 4. Right. Okay, so can I erase? Can I? Right. So for question 4, this one here is the allyl chloride. Okay, give the systematic name of allyl chlorides. So first of all, just write down this one, 1, 2, 3 carbons. So it's a prop, right? But then the position of the double bond, does it really matter? Okay, do you need to label it? Okay, it can be here or it can also be here. But then if you take a look, they are the same compound. So no need to label the position of the double bond. So propene. Okay, but it's understood that this one here is 1 because the name here is at the back. So this one here is a 3-chloropropene. Okay, so it's a 3-chloropropene. Right. Now for part B, the initiation step in this reaction is the formation. Yeah, sorry? Sorry? Yeah, UV lights, correct. So this one here, you can say UV lights. But when you want to say UV light, always spell out the full name, right? Ultraviolet lights. Okay, I believe you studied this in physics, right? Ultraviolet light. Okay, if you forget how to spell ultraviolet, just say sunlight. Okay, both will give you the same marks, right? Right. Now for B part 2, the propanil radical is formed in the first propagation step. Okay, write an equation to show the formation of this radical in the propagation step. Okay, so remember what is the meaning of a propagation? Do you remember? Okay, propagation here is just the one molecule react with one radical. Okay, to form what? To form one new molecule and one new radical. Okay, one new molecule and one new radical. Okay, so like this, right? So now, what can we do here? Okay, so first of all, okay, so let's take a look at the answer, right? What do you think the answer is? Right, so this is the starting reagent, right? So this one here is a C3H6, right? So just write down C3H6 plus what? Plus the chlorine radical that is formed inside the initiation step, okay? And then you will form another molecule. So this one, if you remember from your lecture notes, the new molecule here is a HCl, right? Then just write down C3H5 radical. Okay? Can you see one molecule plus one radical form a one molecule and one radical? Okay, so this is the C3H6. Okay, right. Now let's take a look at part 3. Part 3 here they say, explain why free radical substitution give a low yield of the product that you want. Okay, because why? Remember in the termination step, you produce other products, right? So byproduct is formed. Okay, right. So for this one here, formation of byproducts. Okay, formation of byproducts. You can write this. There's also another answer that you can say, right? Remember the simplest equation for the free radical substitution. This is the general equation. This is when one chlorine goes in, right? But then what happens if you have an excess chlorine, right? When you have an excess chlorine, what happens here is that this one will continue to react with another chlorine molecule, right? And then what will happen here? So it becomes a C2Cl2 plus a HCl. So can you see what happens here? instead of one chlorine going in, now I have two chlorines. So this reaction can happen all the way until CCl4. All right, so how do you describe this in English? All right, so you can say here a further substitution. Okay. Okay, so actually further substitution occurs. Okay, right, so more Cl will go in. All right, it's not just about understanding, it's all about also expressing your answers, right? So this one here, the keyword that the examiner want to see is a further substitution. Okay, further substitution means more than one chlorine can go inside. Okay, because why? You have an excess Cl2. Right. Okay. Now, next one here for part 4, right? Suggests the identity of a reagent X. So this OH changed to a Cl, right? So, sorry, HCl can, right? But you need to say concentrated HCl. Okay, can also. You can also write what? PCl5, right? Okay, PCl3, SOCl2, all this. Okay, so remember what is the name of this reaction? It's called a substitution. Okay, but is it a free radical substitution? It's not, right? Okay, so make sure you know the difference between these two substitutions. Okay. All right. All right. So let's take a look at part C. All right. Ken. Okay. Copy first. Okay. Right. So for part C, suggest a suitable reagent that can be used in reaction 1. So can you see what happens in reaction 1? It's correct. So what Borrowy said, mild oxidation. Okay. So for mild oxidation, what are the reagents? Is it cold or hot? Cold, right? Yes. Cold dilute, acidified KMnO4. Right. Acidified KMnO4. Right. So this one here, this is the answer. Okay. Cold dilute, acidified KMnO4. Okay, next one here, part 2. In reaction 2, the organic product of reaction 1 is mixed with concentrated H2SO4, okay, and then heated and then reflux. State the role of the H2SO4. Identify the organic acid used. Okay, right, so what happens here? In reaction 2, this compound, right, reacts with a H2SO4. Yeah, can you see here? This is your alcohol and then you form an ester. So this is the esterification. Okay, so remember for esterification, the acid here is the catalyst, right? Catalyst. Organic acid here, identify the identity of the organic acid. Yeah, So it's this one, right? But how many carbon? Carboxylic acid? 2, because can you see here there's 2 carbon. So it's a CH3COOH. Okay, right? The name of the mechanism in reaction 3. Okay, so you can see here the Cl with the Cn. Okay, so basically it's actually the Cn minus go in and then the Cl come out, right? So it's a nucleophile, so it's a nucleophilic substitution. Okay, nucleophilic, right, substitution. Okay, so that's the answer for part 3. So remember, there is a SN1 and SN2. So you need to decide whether it is SN1 or SN2. Okay. Okay, any issues? Okay, yeah. Right, so I'm going to erase. Now this one here, the organic product of reaction 3 is a Y. Y can be hydrolyzed using excess H2SO4. Okay, so now draw the molecular formula of Z. Okay, so for this one here, what can you do here? Okay, maybe you can count the number of carbons. Okay, you can count the number of carbons for Y. Okay, whoops. So let's look at Y here. How many carbons? 1, 2, 3, 4, 5, 6. Right, so Y actually got 6 carbon. Okay, and then can you see here it becomes a 4. So it means 2C will come out. So the 2C will come out actually from here, right? Because Y is the reverse of the esterification. Sorry, 8 carbon. Let's count. 1, 2. Hold on now. Yeah, correct. So that's 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon. But then just now it says here become a 4 carbon. So it means minus 4 carbons, right? Okay. So minus 4 carbons. So maybe can come out from here. Okay, 2 carbons, 2 carbons. You destroy the ester bond. Okay. So this one here, what would you get? And also this one here, can you see? Will become a COOH. Hydrolysis, right? So this is the compound. Okay. So please draw this compound. Okay, so like that, right? The ester is broken to form the alcohol, and the CN is hydrolyzed to form the COOH. Right? Yes, any questions? Yes, Borui? Why which one? The OH or the COOH? Both. Why both? Okay. So this one here, just need to remember this reaction here. Right? Need to remember this reaction. Okay, so when I cut the ester bond with the acid, what do I get? I get a R1 OH plus a R2 COOH. Okay? This one here, maybe I'll draw like this. Okay, so now this alcohol here, okay, is actually this one. Okay, just now we got the 2 esters, right? Come out, right? Now this one here, what is this reaction? So remember from your halogenyl alkane notes, this one here, when you react with H2SO4 and then you heat, okay, what would you get? You will get a RCOOH. Okay, so I think you don't know, right? Because you never remember this reaction. Okay, must remember these 2 reactions. Okay? Right, what is the name of this first reaction here? It's called acidic hydrolysis. Okay, hydrolysis. what happens in this reaction? The ester will break, right, into the alcohol plus the carboxylic acid. Okay, so in this reaction here. In this reaction, the name here is also acidic hydrolysis. Okay, also acidic hydrolysis, right? Remember what I said about hydrolysis? It's a very general name. So what is the meaning of a hydrolysis? Okay, it's when a water molecule go inside and then bonds are broken. Okay, so that is always the meaning of a hydrolysis. So this one here, the water molecule is the, can you see here? I formed the water molecule, right? I form this one, H, and then the water. Okay, water molecule go inside and then the water is broken. This one here also the same thing, because why? Can you see? This is from the water molecule, right? This one here is cut. Okay. All right. You can go for your break. Next lesson I'll continue. Okay. Yes, you shall. In the upstairs.